Okay, finally, in the world of arithmetic of radicals, we get to the last operation, which is division. In division, I don't know if you remember this or not, but it's not what you think. We're not going to take like, well, I got this 3 radical 2, and he's going to divide into, that does not how it goes. The trick on this one is basically, remember, it's called rationalizing the denominator. And what that means is basically we multiply top and bottom by something that causes the radicands to become powers of factors to match the root. Watch. Okay, so what I mean by that is a quick example would be if I've got 3 over the square root of 2 and I want to get rid of that square root of 2, then I'm going to multiply by another square root of 2, and I'm going to get upstairs, I multiply 3 times radical 2. Well, that's all there is to that. But downstairs is the square root of 4. And the square root of 4 is 2. Okay? Now notice, I sometimes ask people, so what do you think? Can I cancel the 2's at the end right there? And most people go, no, why not? Because one's a radical and the other is not. So hands off. Okay? Here's some more examples down here. And that's really what division's all about. Let's get rid of that radical downstairs. That's what it's all about, okay? And rationalizing means to make rational, as in a, non-radical, which is an irrational number normally, okay? Okay, here's another example I have right here, and then I have a third example here. These are good for you to read. You can pause it right now and just scan it out. You go, and I typed them up, and it's kind of tedious, but what happens is I'm showing you right, I'll put this in a color. I'm showing you right here. There we go again. I'm multiplying, but all I need is to get rid of the radical. I don't need to multiply by the 2 because the 2 over here, okay, I just need to eliminate that radical. So this is how it's done, okay? So then you get a 5 radical 3, it over 2 times radical, 3 times 3 is 9. And then now the square root, see, I can't square root 3 until I give it another 3. Then it's a 9. Now I can square root 9 to get 3 and get the final answer. Now, it doesn't seem like much is happening, but in the world of mathematics, and I say this all the time, this is indispensable. This is a thing that we want to know how to do, okay? The other one. Now, because we're in intermediate algebra, you're going to have problems with, cube roots. Now, this is an interesting problem, okay? And I kind of gave you a hint when we were doing multiplication in the previous video, but I have a cube root of 5. Look at it. It won't do any good if someone said, why don't you just go 4 over the cube root of 5. Hit them just like you did before, cube root of 5. Great, cube root of 5. Anyone see where this is not going to work very well? 4 cube root of 5 here. And downstairs is the cube root of, I'll write it 5 squared. You see that? When can I cube root a power? When the power and the root match. I need 5 cubed to cube root it. You see that? I need 3 of a kind. That's that old story 2 sections ago. So that's why in this example, I give it 2 more. And whatever you do downstairs, it's got to be identical upstairs, because when you're doing that, you're just multiplying by 1. It doesn't change a thing. Okay, so this is what we wanted. The cube root of 5 cubed gets to cancel, and whatever happens upstairs happens. That looks weird to have a radical 25, but it's the third root, and this guy right here doesn't simplify. Okay, let me get rid of that mark and see that? Pretty cool stuff. So that's the first kind of rationalization of denominators. I think, let's look at these 3 examples. Go ahead and give them a shot. Try the first one right there. We did one very similar right above up here. So give it a shot, pause it and try it. And then we can talk about the other 2 maybe together, unless you know what you're doing. And while you're doing that, I'm going to see what else we got. Yeah, that kind, and, oh, okay. So this is going to be about 12-minute video or something like that, so hang in there. Okay, so this is weird, but did you notice the cube root? So that means we need to give 7, there's only 1 7, we're going to give them a couple more. Because downstairs you end up with the cube root of how many 7s? 1, 2, 3. That's right. That's what we want. But you got to go upstairs with the same thing. That's no big deal. Look what happens upstairs. We have 3 times the cube root of, and then just go 7 times 7 because it's not going to simplify, because there's only 2 of them, 49. But we do simplify here, the cube root of 7 cubed, and we've done it. The downstairs is rational now. It's just a 7. Just a 7. And then upstairs is 3 cube root of 49. That's what it is. That's the answer. How can I tell if I'm doing it right? Well, you know what you could do if you're taking a test and you're going, I don't know if I did that right. I don't care. You should care. What you can do is just put that through a calculator and put that through a calculator, and if they match, you did it right. Of course, you got to realize getting no radical downstairs is the game, and that's happening in all our examples. There's a 2, there's a 6, there's a 5, and now we have a 7. Those are rational numbers. The next one. You ready? I'm ready. Okay, let me write this down here. So I've got 2x over 15. It doesn't look right. Well, I have to struggle with beginning algebra. What you do is you split it apart. Now it looks like a problem that we know how to handle. This is not a terrible problem. Sometimes we see stuff where the 15 is a 12 and you can actually reduce it first. In fact, I think that's going to happen in the next example. Good, I'm glad that's there. What do we do to get rid of a square root? I've got 15, which is 3 times 5, but 3 times 5. But you know what? I'm just going to come in with another 15. Okay? Because downstairs what happens is you end up with the square root, I'll just write it this way, of 15 squared. I don't care what that's actually equal to, 225 or whatever the heck it is. But then downstairs, that's the important thing, you get the 15. 15 is released into the wild. But you got to go upstairs with 15 also. Okay? And that radical upstairs, radical 2x multiplies with that guy, radical 15, to produce what? The square root of 30x. So I've got the square root of 30x. What do you think about 30? Did you watch my other video? 30 doesn't go anywhere. 30 is 3 times 10, which is 2 times 5. 1 factor, 1 factor, 1 factor. I don't have any squares, so this one's done. Okay. Now try this one. I have a recommendation on this one. If you don't mind, I'll tell you what it is. The 18, all right, the 18 just bugs me because it's unsimplified. It's so unsimplified. So, you can do this problem the way I just did the previous one, which is to multiply top and bottom by radical 18. Then you're going to have to simplify a radical and cancel. In other words, you can simplify at the front end, or you can do your work and then simplify at the back end. Sounds like you should do the back end, but actually, I'm not going to do it that way. I like to go after this guy and go, I know that 18, I'm starting to get better with these numbers, I hope you are too, is 9 times 10. 9 times 2. So I am going to go after simplifying radical 18. It's the square root of 9 times 2, and so it's going to make our work easier when we get to rationalizing. So we end up with 3 square root of 2. Mr. Weber, yes. Mr. Weber, yes, student, what is it? Can I cancel the 3's? Can you? Are they one radical, one's not? No, those are raw 3's, you bet. Great idea. They're gone. We just simplified the problem, and now it's really looking like the square root of 5 over the square root of 2. Are we done? That's enough work. I think I'm done. You're not done. Is there a radical downstairs? Yes. Well, then you've got to get rid of it. Now we're going to hit it with radical 2 over radical 2. Okay? And what we get is radical 10 over radical 4, which is the square root of 10 over 2. And are we done? Can I cancel the 10? No. One's a radical, one is not, and that one's done. Okay? That's one type of rationalizing the denominator. I'm going to move on. I think it's, like I said, going to be a slightly lengthy video, but that's pretty good stuff right there. The other, you can pause it. Pause. The other kind of rationalizing is when they test us with something that looks like, oh, I've got 4 over radical 3 or square root of 3, but then they add like a -1 or +5 or something like that. Well, how do we deal with that guy? Well, I've got an example written out right here. Here's this guy, and it goes, we take advantage of the difference of squares pattern. This time I wrote it in, because we did one of these in a previous video. We foiled that stuff. And when you foil that stuff, you have this cancellation right there. And this guy turns to 7, and you get a 2. And look at that. It's rational. And you know what? It also reduces down. That can happen sometimes too. So here's a couple of problems for us to practice. Then I have one more example after this, and we're done with this video. Okay, try it. What do we multiply by top and bottom to make this guy rationalized? If I had $1 for every time a student goes, I think it's just radical 3 because that's what we've been doing all this time, it's not going to work. Because if you FOIL this or distribute, you go, okay, that's a radical 9, but guess what? Now you have a minus radical 3 if you're sticking with the rules here, right? No, that's not how to do it. It won't work. Instead, we follow this example. I want 1 to be plus, I want 1 to be minus. The problem has the minus. We go with the plus. Okay? Groovy. Okay, so what do we have? What we have is, now we multiply across the top. Now watch Weber do his little thing. I'm not going to mess with that 4. I'm just going to leave it alone. You know why? Downstairs might be a number that 4 cancels with. So I don't want to multiply and then refactor and cancel. You know what I mean? You'll see. Downstairs, though, what we got is this guy, radical 3 minus 1 and radical 3 plus 1. And I know, look up here, I know the inner and outer product of the FOIL is going to cancel. But if you want to see it, all right, I'll do it. So 4 radical 3 plus 1 here. Here we go. You ready? Ooh, that looks messy. Because it is. Well, if you want the table, you can work the table. If you do that, you're going to get a square root of 9. See, I'm saving us some time here. Then we're going to get a plus radical 3, then a minus radical 3. What happens there? And then a minus 1. Yeah, they cancel. That's why we're doing it. Right there, they cancel. The difference of squares pattern makes that happen. So whenever you do a binomial, you make the difference of squares happen, and you lose the radical that way. So what do we have? We have done it. We've hit the home run. We're just watching it sail over the fence now. Radical 9 is really 3 minus 1. It's going. It's going. It's gone. I think my mind is gone. I don't know. And 3 minus 1 is 2. And see, the 4 and the 2, that's why I leave the 4 alone. I just go cancel, cancel 2. We get this wonderful answer, red hot answer, 2 times the square root of 3 plus 1, done. That's how division with a binomial goes. Try the next one, but it's a mess. But try it anyway, okay? You can pause the video and see how that goes for you, okay? So I've got radical 11 plus radical 5. The numerator is a mess, okay? And then we have radical 7. I took this from the book, I think, minus radical 3. It's a tough one, right? We're going to multiply top and bottom. We're going to create the difference of squares pattern downstairs. Once again, they gave us the minus, so once again, we choose the plus. If a person is not following this, they might think, oh, he always just goes plus. Listen to me. We're creating a difference of squares down there. If this was a plus, then you would go minus, okay? And if it's minus, as it was in these two examples, which, oops, oh well, you go plus. So let's see, we're going to write it out mechanically. We've got radical 11 plus radical 5 meets radical 7 plus radical 3. Well, that's going to be fun. Should I leave that alone? Interesting question. I don't think these guys, as is, are going to cancel with anybody. So it's a matter of really what form of the answer am I looking for? Downstairs, we have radical set. We're going to have the square root of 49. Now, I'm foiling in my head, but again, you can go to the table here and work it out. Then we're going to have a plus radical 21, a minus square root of 21. Do you see this? Yeah. Right here. There's the minus square root of 21 right there. And then finally, minus square root 9. Now, the beauty of it is we got, once again, right, the cancellation. So we have upstairs is radical whatever, but downstairs, this is what we're getting. We're getting square root of 49 is 7, minus square root of 9 is 3. That is what you're aiming for, baby. You got a 4. Now, upstairs, I'm going to foil it because I think my math lab would probably want you to. I don't want to, but I think I will. I'm going to go square root of 77. Does that reduce? No, it's 7 times 11. They're prime. Square root of 33, so plus the square root of 33. Okay. Look at that one. Plus the square root of 35. And finally, plus the square root of 15. Woo! Boy, that was fun. And if you want, I don't like this answer, but it is what it is. My friend says that a lot. And then plus square root of 15. Okay, so hideous looking numerator, but we did it. They wanted us to do it. We did it. Okay, the last example, and we're really eating up the time here on this one. This is also in the homework. Basically, it can help us combine like radicals. So this particular, watch how this one works. What you're supposed to do is simplify. So you do what you can. Okay, 5 radical 2, there's not much I can say. I have seen 50 so many times now. It's square root of 25 times 2. So in the next stage or step, what's going to happen to him is he's going to become a 5. Oh my gosh, it's another 5 radical 2. This one I also stole from the book. Isn't it cute? But look at this last one. I'll put this in another color maybe. Blue. Okay. So this last one is minus 2 over the square root of 8. I'm going to simplify that as I did before. I'm going to call it 4 times 2. So it's minus 2 over 2 radical 2. And keep working. So I've got 5 radical 2 minus, goodbye 2's, 1 over radical 2, and then plus 5 radical 2. Now I can combine the first and last if I want, but what I'm going to do next is I'm going to rationalize the denominator using a radical 2. Okay, and let's see what happens. So you get a 5 square root of 2 minus radical 2 over radical 4 plus 5 square root of 2. Okay, you know what? I'm going to put those two together, these guys. So 10 square root of 2 minus radical 2 over 2. And you think, oh, they don't combine. Yeah, they do. Watch. This is 10 square roots of 2 minus 1/2 square root 2. Are you kidding me? We're going to add those numbers. This is over 1, so times 2 for a common denominator. What I've got is 20 halves minus 1/2 radical 2. I'm adding them. You can do a calculator. So that's 19 halves. So 19 over 2 square root of 2 is a decent answer. Thanks for listening. That was a lengthy one. That's division, but I figured we'd just fit it all in tonight for that one. 19 minutes. Whew.